Assuming you are given a question in electrolysis, in any examination, and you don't know how to attempt it. Now, I will like to help you out here by explaining the mechanism of electrolysis. What is electrolysis? Electrolysis is the chemical decomposition of an electrolyte by the passage of a direct current through the electrolyte via the anode, via the electrode. Now, what does an electrolyte mean? Electrolytes can be a salt or a compound. It can be an acid or any compound in molten form or in solution that allow the passage of electric current through them. It means when they are in form of solid or there is no traces of water in them, they cannot conduct electricity. What do we mean by electrode? Electrode can be made up of two types. We have the anode and the cathode. Now, in an electrolytic setup, this is an electrolytic setup where you have a container or an electrolytic material containing an electrolyte. Electrolytes, I've explained the meaning of electrolyte here, with which we have two electrodes inserted. Now, the two electrodes can be positive and negative, meaning that on one side we have the anode, which is positive, and on the other side we have the cathode, which is negative. Then a cell is connected. A cell is connected to this electrolytic setup, or a battery. Now, in this case, you can see the direction of the arrow. At the anode here, something begins to happen. Immediately, there is a passage of a direct current through this battery, through the electrode, inside the electrolyte. There will be a kind of movement. Now, the compound inside the container is actually made up of hydrochloric acid and water because it's diluted. So the ions are hydrogen chloride, chloride ion, hydrogen ion, chloride ion, hydrogen ion of water, and hydroxy ion of water. These are the four ions. Now, when a direct current is passed through, there will be a kind of movement. Now, what are the ions that will go to the anode? Don't forget the anode is positive here, and the cathode is negative. The ions that will go to the positive anode are the negative ions, which are chloride ion and hydroxyl ion. The ions that will go to the cathode are hydrogen ion of water and hydrogen ion of cathode. So at this junction, there are three mechanisms, or three factors rather, that affect the preferential discharge. Which one will be discharged? That's why we are using the word preferential, because two ions will be competing and one will be discharged in preference to the other. Although at the cathode here, there is only hydrogen. So there is no competition of any sort. So these two ions goes to the anode. Which one will be discharged? That is where we apply three factors that affect preferential discharge of ions. Number one, we have the position of ions in the electrochemical series. We also have the concentration of the ions in the electrolyte. Then we have the nature of the electrode. Now, let's quickly look at the first factor, which is the position of ions in the electrochemical series. At this point, we need to know the arrangement of metals according to their reactivities, and the arrangement of negative ions according to their reactivities, using this acronym. Popular, that is K. Scientist, sodium. Can, that is calcium. Make, magnesium. Zu, aluminium. Zu, zinc. In, that is iron. D, that is tin. Low, that is lead. Humid, that is hydrogen. Country, copper. More, that is mercury. Satisfactory, that is silver. Ag. Good, that is gold. Now, with this, we also have the negative aspect. Aus, in, that is iodide ion. Big, that is bromide ion. Castu, that is chloride ion. Normally, that is NO3 minus. Sounds, that is SO4 2 minus. Funny, fluoride ion. Now, looking at this arrangement, this part here, as we go down this group, we can see that the reactivity or electropositivity is decreasing. So any element found down here, assuming in this electrolysis of dilute hydrochloric acid, which is also known as acidified water. That is adding few drops of acid in water, a large quantity of water. Now the ions here are chloride ion, hydroxy ion for negative part. Then we have the just hydrogen ion for let's use in the electrolysis of sodium chloride, dilute sodium chloride. Dilute sodium chloride. In the electrolysis of dilute sodium chloride, we have the ions of sodium chloride and the ions of water. And the ions here can be split into sodium ion, chloride ion, hydrogen ion, and hydroxy ion. Now, as you go down the group, the reactivity decreases. We can see here that just the ions of sodium and hydrogen are competing at the cathode. They are going to the cathode, and one will be preferentially discharged here. So which one will be discharged? That is when we make use of the position of ions in the electrochemical series. Let's look at this. The two ions here, sodium ion and hydrogen ion, are competing at the cathode, which is the negative electrode. The positive ion goes there. So you're making use of the or the activity series here now. It is found that hydrogen is lower than sodium ion in the activity series. So the rule says any ion that is lower in the series will be discharged in preference to the other one. So here now, hydrogen ion will be discharged at the cathode. And then at the cathode, reduction always takes place. Reduction in terms of electron transfer is a gain of electron. While at the anode, oxidation usually takes place, and that is loss of electron. So since hydrogen ion is discharged at the cathode, hydrogen ion is going to gain electron. And the equation will be written as this. Hydrogen plus 1 electron, because it's carrying only one positive charge. So it's gaining 1 electron to become H, just neutral. But because we can't write hydrogen gas as just H, another hydrogen atom combined to give you hydrogen gas or molecule. So the overall equation will be H plus E minus to give H plus. To balance this, now we have 2 atoms here. So we need to add 2 to this hydrogen side, hydrogen ion side, 2 electrons. So making the equation to be balanced. 2 hydrogen ion is gaining 2 electrons to give 2 atoms of hydrogen. So at the anode now, at the anode, oxidation takes place, which is a loss of electron. So these 2 competing ions are at the anode. Which one will be discharged in preference to the other? Now take note of the electronegative series here. Ounce in big gas 2 normally sound funny. Now, as we go down the group, electronegativity increases. This fluoride ion is the most electronegative. So which one is lower? The lowest electronegative. The least electronegative is hydroxide ion. Please don't forget that the way I do this is different. It decreases down, the electropositivity decreases down the group, but for electronegative series here, the electronegativity increases as you go down. No, so in this case now, hydroxide ion is the least, and it will be discharged in preference to chloride ion. So to write the equation, since oxidation usually occur at the anode, which is loss of electron, hydroxide ion is going to lose electron. That's, we have OH neutral, no charges again with this charge, to lose 1 electron. But we don't write hydroxy ion like this. So hydroxy ion combined with another hydroxy ion to give you H2O, and the remaining oxygen is written here. So oxygen is also diatomic. So we write it as O plus O to give you O2. So the overall equation here is OH minus to give water, that's H2O, and oxygen, which is O2, and electron. Balancing the whole equation, hydrogen here is 2, oxygen is 3. If you add 2 here, oxygen will be 2 here and 2 here, making it 4. Hydrogen is already 2 times 2, which is also 4. So we need to add 4 electrons to this, making sure that the equation is balanced and the number of electrons is balanced. So on this side too, we can also add 4, making hydrogen and oxygen ion balanced here. So this is the overall equation. Looking at the whole thing, we can see that the only visible particle that we will see here is the oxygen gas that will be liberated at the anode, while hydrogen gas will be liberated at the cathode. Water will go back to solution, and the chloride ion is also going back to solution because hydroxide ion is preferentially discharged. Since chloride ion is going back to solution, and sodium chloride will be retained in the remaining solution. because sodium has gone back from here. Hydrogen is discharged, sodium has gone back. Chloride ion has gone back because hydroxide ion is discharged. So, in a nutshell, using position of ions in the electrochemical series, we will get hydrogen and oxygen on both sides respectively. Now, using the remaining two factors, we know we have three factors affecting preferential discharge of ions in the electrochemical series. We have the position of ions in the electrochemical series, we have the nature of the electrode, and also we have the concentration of the electrode. Now, I will use the concentration of the electrode to attempt this question here. Now, we will still use this chart. Using the second factor that affects preferential discharge of ion, which is the concentration of the ions in the electrolyte. Now, we have two factors. We have the position of ions, which has been earlier discussed. Now, what is discharge at the anode in the electrolysis of concentrated solution of copper 2 tetraoxosulfate 6 if a platinum anode is used? Now, here we have to consider the anode used. That's an electrode. We have the anode and cathode as the electrode. The anode is positive while the electrode is while the cathode is negative. Now, platinum does not have any effect on the electrolyte. So we are not discussing nature of electrode now. We want to look at the concentration. If you take note of the electrolyte used there, it's concentrated solution of copper 2 sulfate. Now, if you are working on the electrolysis of concentrated solution, the rule says that even if in the electrochemical series, the ions lower in the series is supposed to be discharged in preference to the one higher in the series, just as in the case of position, the electrolysis of sodium chloride, in which you have sodium ion and hydrogen ion from sodium chloride and water respectively. Hydrogen ion is from water, while sodium ion is from sodium chloride. The sodium is up while hydrogen is down. Hydrogen is discharged in preference to sodium in that case because hydrogen is lower in the series. But considering the electrolyte used here, in the former one it was dilute sodium chloride, but in this case concentrated copper sulfate. The rule says that if an ion is concentrated, it will be discharged in preference to the one if that is lower than heat, even if it is high in the electrochemical series. But this rule can only work if the distance between the two competing ions are not too far. But if the distance is far, the one lower will still be discharged. The effect of concentration will no longer work. So in the electrolysis of copper sulfate, we have just two ions, copper 2 ions, and we have 4, but these two ions are high. While for water, since it's concentrated, the concentration of water here, which is hydrogen ion and hydroxide ion, they are very low. Now, let's pick the first two. This is an electrolytic setup. We have the anode and the cathode here. Now, this is the battery connected, and this is the direction of the arrow. At the anode here, oxidation takes place, which is loss of electron. So at the anode, negative ions will migrate to the positive anode, while at the cathode here, positive ion will migrate to the negative cathode. Now, what are the negative ions? Tetrasulfate 6 ion and hydroxide ion are going to the anode here. Which one will be discharged? Don't forget we are considering the effect of factors. This the ion of SO42 minus is higher than that of hydroxide ion. So considering this now, let's look at the position in the electrochemical series. Arrows in big castle normally sound funny. Now we can see that SO42 minus is higher. Looking at this, the way I drew this negative series, as we go down, the electronegativity increases. So SO42 minus is greater than hydroxide ion. Hydroxide ion is lower. Though it is up here, it is lower, it's the least electronegative. And SO42 minus is highly concentrated compared to this, based on the electrolyte used there. Now, the rule says we are supposed to consider SO42 minus being discharged. But the problem here is that the position, provided the position is not of the two competing ions are not far. But in this case now, the distance is still far. So hydroxide ion will still be discharged at the anode. So in that case, if you are writing the general equation, sorry, at the at the anode, hydroxyl ion will be discharged. It's going to lose electron. There is a loss of electron at the anode. That is oxidation to give you OH. Now, if you are writing this, we write it as, you can also write loss of electron as E minus here. Now, here we need to balance this because there's nothing like OH, so we have OH plus OH to give you water, and balancing the whole thing, OH minus gives water plus electron. This is plus oxygen as well, H2O and oxygen. Now plus O plus electron. Now oxygen combined with another oxygen to give you O2. So the overall equation is OH minus to give water plus oxygen plus electron on this side. Balancing the whole thing, we have 4 here. We have 2 here to make this 4. Oxygen is 2 here, making it 4. And then we have 4 electron here. The whole thing is balanced. So at the end, oxygen will be discharged. Anytime there is electrolysis and then hydroxyl ion is being preferentially discharged, it is oxygen that will be liberated at the end, and 4 electrons, which means 4 Faradays, will be used up. So at the other side, which is a copper 2 ion and copper 2 ion and hydrogen ion, that will go to the cathode. These positive ions will go to the cathode. Which one will be discharged? Because the concentration of copper 2 ion is higher than the concentration of hydrogen ion, and it is still lower. Copper 2 ion is even lower than hydrogen ion, and because the concentration is higher, it will be discharged. So at the cathode, we have copper 2 ion. Don't forget, reduction takes place at the cathode, oxidation takes place at the anode. So copper 2 ion is going to gain electron. That is reduction. Oxidation is loss of electron to give you, but because copper is carrying 2, we have 2 electrons here that will be gained to give you just copper. So this is the overall equation. Copper will be discharged at the the mass of copper will be discharged at the cathode, while oxygen gas will be discharged at the anode. So now what is the question? What is discharged at the anode in the electrolysis of concentrated solution of copper 2 soft tetraoxide 6 ion if a platinum electrode is anode is used? So at the anode, the answer is oxygen. At the cathode, it is copper. So the best answer here is option C. Now we need to really understand the principle behind this electrolysis to be able to answer questions on this, and this principle will also be used in calculation. So you should watch out for my videos on calculation. While I quickly treat the last question here, which is on the effect of the nature of the electrode. I told you 3 factors affect preferential discharge of ions. We have the position of ions in the electrochemical series. Using this, we have the concentration of the electrolyte, which has been used to answer this question, and then the last one is the nature of the electrode. These are the 3 factors that affect preferential discharge of ions. Now, to work on that, it is generally known that platinum, though it is inert, it does not is a form of electrode that does not affect the electrolyte. Carbon is also a form of electrode that is inert, it doesn't affect the electrolyte. But the only thing, and also mercury electrode does not affect the electrolyte, only that at times they interfere with the gas discharged. For instance, now if platinum is involved in an electrolyte involving chlorine, the chlorine gas discharge can interfere or can react with the platinum. Carbon can also be attacked by oxygen gas. Carbon in this case is a graphite that is used as electrolyte. Oxygen gas liberated can also affect it. Then for sodium, if sodium is used in the electrolyte and then mercury electrode is used, in this case, this is what we refer to as electrode in electrolysis. Anyways, this is a battery. So these are the electrodes I'm talking about. Platinum can be used on both sides as anode and cathode. So any of these can be used. Carbon can be used on both sides. Mercury can be used on both sides or one. Now, if mercury is used, sodium can interfere with it to form sodium amalgam. But there is another thing. If you use copper, for instance, now you use copper as the as the anode here, if you use copper anode, and then you are working on electrolysis of copper sulfate, dilute copper sulfate. We have copper 2 ion, we have SO4 2 ion, then we have hydrogen ion and hydroxyl ion. Now the positive ions here will go to the cathode, which is negative, and the negative ions will go to the anode. But the problem is, if copper is used as cathode, there is no problem. But if copper is used as anode here, there will be problem, because provided the copper anode is the same with the solution, is carrying the one of the ions of the electrolyte, there will be problem, because instead of hydroxyl ion being discharged, these two competing ions will go. The one that is lower will be discharged, which is hydroxyl ion. Instead of hydroxyl ion being discharged, copper itself will dissolve. This is copper atom, which is neutral. It will dissolve by losing electron. It will lose electron and become copper 2 ion. When elements lose, they become ions. Now these copper 2 ions will now go into solution. Already we have copper 2 ions in solution here, copper 2 ions, because as a result of this electrolyte, and we have hydrogen ion and hydroxyl ion. Copper 2 ions that are already going to the cathode, the copper anode dissolving here will also join them, and everything will be deposited on this side. You will see an increase in the mass of copper discharged here, because ordinarily copper will be discharged based on the position of ion in the electrochemical cycle. It is lower than hydrogen, so any ion that is lower will be discharged. So this is the effect of using copper electrode, and this principle is used in the electroplating or purification of metals. Now we can have a silver cup here, for instance, now, and then use a silver anode, use silver triazonitrate as the electrolyte, because the cup here maybe is made up of iron and we want to coat it with silver. The silver will go into solution, dissolve, and be coated on the surface of the cup here. This is the principle behind this reaction. So using this during the electrolysis of brine, that's sodium chloride and sodium hydroxide, using a mercury cathode, which of these, all right, during the electrolysis of brine using a mercury cathode, which of the following is not generated on the addition of water to sodium amalgam? Now, sodium reacts with mercury. Sodium in the ions reacts with the mercury as the electrode. Now, when water is added to such reaction, we end up getting this splits into hydrogen ion and hydroxyl ion, which splits into NaOH, because Na here carries +1. It combines with this, they cancel out to give you NaOH, and then we have hydrogen here is written as hydrogen gas, and then mercury is liberated. So the odd one out here is oxygen. Hydrogen will be discharged, mercury will be produced, sodium hydroxide will be produced, hydrogen will be produced. Thank you. For the remaining part of this video, which is calculation in electrolysis, very soon, which will be uploaded very soon. Thank you. Don't forget to subscribe to my channel, like my video, share my video, and press on the notification bell to get alerted anytime I drop new videos. Thank you.